So today we're going to be covering Algebra 2 factoring. We're going to specifically cover two different types. We're going to do the factoring sum and difference of perfect cubes, and we're also going to be doing quadratic form, and I'll show you what I mean by both of those. With that, just as a reminder, in Algebra 2, factoring is really important, and so we really want to make sure that whenever we hit factoring techniques that we not only understand them, but that we can do them and that we're practicing for future. So we are going to start with factoring sum or difference of perfect cubes. And so in order to do that, we have to review what perfect cubes are. So let's see here. I'm just going to do this here. So so 1 cubed, what's 1 cubed? Isn't it 1? Right? 1 is a perfect cube. 2 cubed, right? 2 times 2 times 2 is 8. 8 is a perfect cube. 3 cubed is 27. Good. 4 cubed. Now we're starting to get a little bit harder, right? 64. 5 cubed. 5 times 5 is 25. And then if you have 5 25s, it's $1.25, right? 5 quarters, so 125. And then 6 cubed is 216. So if I'd memorize up to those and then recognize that 7 cubed is 343, 8 cubed is 512, 9 cubed, 729, and then 10 cubed is 1,000. A 1 with 3 zeros. Okay, so now factoring sum and difference of perfect cubes. I like to do this with a pattern, okay? But the book, they always have they like to write out the pattern, and I like to give you the pattern to follow. So whenever you see perfect cubes and you think of factoring them, I want you to think about small group, big group. Okay, so small group, big group. Small group meaning that it's a group of 2 terms, big group meaning that it's a group of 3 terms. So I'll just review, right, when they say sum or difference of perfect cubes, so you can see here, right, do you see I have 2 terms in this one? And you see that the first term is a perfect cube and the second term is a perfect cube. And you can see that it's a sum. Right? And then the second one, you can see here that you have the difference of perfect cubes, right? The first one's a perfect cube, the second one's a perfect cube, and you have the difference sign between them. Okay, so now the pattern goes like this, right? The small group is just going to be these terms brought down without the cubes. Don't worry, we're going to practice this. And then the big group, you square the first one here and you square the last one there. And then to come up with that middle term, you're going to multiply these together and change the sign. And it's the same for this one, right? You're going to square the first and square the last. And then you're going to multiply them together and change the sign, and that gives you the middle term. Let's do it this way. So let's look at x cubed minus 27 here in example 1. And so if we're looking at x cubed minus 27, first thing I ask is x cubed a perfect cube? And at this point, you're all nodding your heads, right? Because it's got the cube on it. Well, that makes that nice and easy. So what about 27? Is 27 a perfect cube? We look up above, right? We can see it's right here, right? It's 3 cubed. So hopefully you're memorizing that. And so then I'll just write it this way, as 3 cubed. So this is the difference of perfect cubes, isn't it? So what I'm going to do is I'm going to think small group, big group. So I need a group big enough for 2 and a group big enough for 3 terms. Are we okay with that? And the small group is always easy. You always bring down the terms here, just leaving out the cube. So it becomes x minus 3. Are you guys okay with that? To get the big group, what you're going to do is you're going to take the first term here, and you're going to square it. When you square x, you get x squared. Then you're going to take the minus 3, and you're going to square that and put it as the last term of the group. Well, when you square a negative 3, what do you get? When you square negative 3, what do you get? 9, good. So now I'm left with the middle term. And the way that you get the middle term is you're going to multiply these two together, and you're going to change the sign. So I'll write it here, multiply together and change the sign. Okay, so what's x times negative 3? Right, because you're going to multiply, you are going to multiply the x and the negative 3 together. So what is x times negative 3? Negative 3x. And then you are going to change the sign. So the negative 3x becomes positive 3x. Okay, now you're going to use SOAP. Okay, this is an acronym to double check your signs. So what does SOAP stand for? Okay, the first one is same, meaning that it's the same sign in the group. So the sign that is in this location right here is the same as the sign above. Got it? So do I have the same sign? And the answer is yes. Okay, so, I should write same sign. So what does the O stand for? Okay, well, the O is the opposite sign. So this one's the same, and then the next sign, that's this one right here, that one's the opposite. So this is always going to be whatever opposite of whatever is in this location. So this one's a subtraction, so this one here would be expected to be addition. I'm going to move that over a little bit. Okay. And then the next one is the A and the P, and they actually go together here. And the A stands for always, and the P, positive. Or always plus would probably even be better. So the last sign is always a plus sign. So I'm going to look here. Is that a plus sign? And the answer is yes. So therefore, our signs are right. We've checked our signs with SOAP. Clear? Okay, let's do another example here. You always ask if there's a GCF when you come to these problems. Is there a GCF for 512 and 125? And the answer is no, there's no GCF. Then I can ask, well, there's two terms. So when you see two terms, you should always think GCF, which I just checked for, difference of squares, or some difference of cubes. Well, I see the cubes, so it's not squares. So I just have to ask, is 512 a perfect cube? Do we see it up in our list above? And it happens to be 8 cubed. So I'm going to rewrite this first term, the 512n cubed. I can write that as 8n and that whole thing to the third. Do you guys agree with that? Okay. And then minus 125m cubed. Is 125 a perfect cube? And it is, right? It's up there. It's 5 cubed. So I can rewrite this to be 5m quantity cubed. Okay, so it looks like it's the difference of cubes, and so I can do my small group, big group. And remember the small group, you write exactly what you have above, you just leave off the cube. So it'll be 8n minus 5m. Are we okay with that? And then I'm going to take the first term here. I'm going to square it, put it there. What is 8n when I square the whole thing? 64n squared. Notice I squared the 8 and I squared the n. I'm squaring the whole term. Clear? I do the same thing with the minus 5m. When I square the minus 5m, you're going to get plus 25m squared. Now I have to multiply these two together and change the sign. So I'll say here, multiply together and change the sign. So what is 8n times negative 5m? Well, what's 8 times negative 5? Negative 40, and then n times m. So that will be negative 40 m n. Oops, I ran out of room. I'm going to just move this over just a little bit. How are we doing? Okay, so those were both difference of cubes. The next two are sums of cubes. But you know what? The sums of cubes, they're no different. So if I have y cubed plus 125, first I'm going to look, is there a GCF? Nope. Is it sum or difference? I'm sorry, is it difference of squares? Well, no, it's not difference, so that takes it away, and I can see they're not squares either. And then I'm going to ask, can I rewrite it as the sum or difference of cubes? Well, y cubed obviously is a cube, but what about 125? Well, isn't that 5 cubed from up above? So I can rewrite my small group and my big group. So small group is exactly what we have here. Big group, you're going to square the first one, which is y squared. You're going to square the last one, plus 25, and then you're going to multiply together and change the sign. So y times plus 5 is plus 5y. Changing the sign gives me minus 5y. Oh, I forgot to use soap to check my signs last time, didn't I? Let's just double check here, right? Is this one the same sign? Yep. Is this one the opposite of this sign? Yep. And this one's always positive, and it was plus. Got it? Notice if I go back on example 2, I can do the same thing. Is this one the same sign? Yep. Is the next one opposite? No, you guys let me get away with that. Okay, so that should be plus 40 because you have to change the sign, right? We multiplied it together, but we didn't change the sign. And then the last one's always plus. Is it a plus sign at the end? And the answer is yes, so we're good there. Ooh, nice catch. Okay, so let's try the next one. 64 is a perfect cube. It happens to be 4 cubed. And then obviously m cubed. There is no GCF, right? I should be asking that question. There's no GCF. So I'm going to write my small group, big group, because it looks like it's the sum of cubes. Why don't you guys try and factor this one and compare it with mine? Make sure you use SOAP to check your answers, and when you're done, compare with mine. I got 4 plus m times the quantity 16 minus 4m plus m squared. Okay, how are we doing? We're good? Okay, so then this last one, oh, I noticed, do you guys see there's a GCF this time? Do you see it? Both terms have the 2, and both terms have x's, the smaller x's too. So I can take out a 2x squared. So I'll do that here. So 2x squared. And when I factor that out, I'm left with x cubed minus 8. X cubed minus 8. That looks like some difference of cubes, so I'll rewrite this. So 2x squared, and this is x cubed minus 2 cubed. So I'm going to factor that to be big group, small group. Okay, I'll bring down the 2x squared in the front. And then notice, right, I'm going to square the first term. Square the last term. That'll give me plus 4. Okay, and I'm going to multiply these together and change the sign. And I'll use soap to check my signs. Well, I got 2x squared times the quantity x minus 2 times the quantity x squared plus 2x plus 4. We all together? Okay. Let's move on then. Let's take a look at the next type of, oh, by the way, before I forget, one thing I do want to just say, this term here, the common mistake on this one is instead of memorizing multiply together and change the sign, I get double the product, right? Because the square root of the left, square root of the right, double the product, and fight. That has to do with expanding a binomial. So in factoring, difference of cubes, remember this is multiply together, change the sign. Okay, so let's come down here and we're going to be factoring trinomials in quadratic form. Okay, so quadratic form means that we can rewrite it so that it is in a quadratic form. And so in order to do that, it has to meet the following criteria. So I will write here quadratic form. Okay, so if it's going to fall in quadratic form, 3 things have to be true. So you have to check all 3 boxes. So the first box is that it's a trinomial. The second is that there has to be a constant. Okay, and the third, okay, if you double the middle exponent, it has to equal to the first exponent. So all 3 criteria have to be met. So take a look at example 6 here. Okay. So for example 6, is it a trinomial? Does it have 3 terms? Well, there's 1 here, there's 2, there's 3. So is there 3 terms? Yep, so I can check that box. Okay. Is there a constant term? Sure is. So I get to check that box. And the third one is if the middle exponent is, if you double the middle exponent, do you get the first? So I go here. Here's the middle exponent. If I double it, do I get the first? Is doubling 2 4? Of course. So I've met all three. So what does this tell me? Well, I'm going to rewrite this. Okay, and this is how I'm going to rewrite it. I'm going to rewrite where we have m's. So this first one, okay, I'm going to rewrite it as squared. I'm going to put the middle term here. So I'm going to rewrite the first term in terms of the middle term. So it'll be m squared, which is the middle term, and then squared. Well, actually here, let's do this. So I'm going to take the middle term here, and that's what we're going to write there. So it's going to be m squared squared, and then I'm going to do this again. So it's plus 11, right, times, right, and then I'll just leave it, I'll write it this way, m squared, and then plus the 30. Okay, do you guys agree that that second line is equivalent to the first line? Yeah? Okay, so this is what I'm going to do now. I'm going to use this really cool substitution technique. I'm going to pick any letter I want. I'm going to actually use capital A, because when I use a capital letter, it reminds me that I'm using a substitution technique, so that I need to put it back to the original. And I'm going to rewrite the line that we have here in terms of A instead of M. So A is going to be equal to M squared. So every time I have an m squared, I'll replace it with an a. So this becomes a squared plus 11a plus 30. Okay, are we okay with that? Okay, and it has the leading 1, doesn't it? Right here. So this actually is going to factor nice and neat. You guys remember 2 groups? Right, we know A will be in the front of both groups, and we're going to ask, what are factors of 30 that add to be 11? Are there factors of 30 that add to be 11? 6 and 5? Yeah? So I'm going to add 6 here, add 5 there. Are we good with that? Okay, so I'm looking there. I can't factor what I have there in green further. So it's time to put back in what A is. A is the m squared. So I'll rewrite this to be m squared plus 6. And I'll rewrite this one here to be m squared plus 5. And because we're in Algebra 2, we do need to ask, can we factor more? Do either of those terms factor more? M squared plus 6. I see the m squared. I know that's a perfect square. I see 2 terms. Is it the difference of perfect squares, this one here? No, it's same with the second. So does this factor more? And the answer is going to be no. So that'll be my answer. So quadratic form is we're able to rewrite it as a quadratic, and then we can factor it. All right, let's take a look at example 7. I don't want to write it all out again, but for example 7, do we have 3 terms? A trinomial, right? We're going through this here. We're now applying it to this problem. Okay, so do we have a trinomial? I'll put the boxes here. How's that? Yeah, we have 3 terms. So I can check that off. Do we have a constant? Sure do. So I get to check that box. And when I double the middle exponent, the 2, do I get the first? I sure do. So I've checked all 3 boxes. So I'm going to rewrite that so that it's going to be something squared minus 34 times something plus 225. Okay, and you're always going to rewrite that something, right, that I didn't write, that the x squared that's in the middle. You're going to rewrite and put the x squared here. And notice the x squared is x to the 4th. And then this is already x squared. So is that second line equivalent to the first line? Sure is. So now I can use my substitution technique. So I can let a be equal to the x squared. And I can now rewrite this line to be a squared minus 34a plus 225. Okay, now this one's a little bit harder, but it does have a leading 1, so that makes it pretty more straightforward to factor. So I can make my 2 groups. I know I'm going to have A and A. So we're looking for 2 things that multiply to be 225, that add to be negative 34. And I'm just going to tell you what it is. It's negative 25 and negative 9. Are you okay if I do that? Now I notice it can't be factored any further, so I can rewrite this again here. So now it's going to be x squared minus 25, and then here, right, x squared, and then minus 9. Can that be factored further? The answer is yes. So here, x squared, right? This is a perfect square. X times x, 25 is a perfect square. 5 times 5, and you can see that it's difference. So I get to rewrite that as 2 groups, where one's plus, one's minus, right? And then it's x in the front, 5 in the back. X plus 5, x minus 5. Notice here, this is also difference of squares, x times x and 3 times 3. So I can rewrite that in 2 groups, where one is plus and one is minus. Put the x's in the front, the 3's in the back. Okay, and then I'll write that one more time. X plus 5, x minus 5, x plus 3, x minus 3. Can I factor again now? No, that's as far as we can go. How are we doing? Are we good? Okay. I think I have a couple more examples here. I'm going to go ahead and go up. Okay, example 4. Since my checklist is now off the screen, I'll just write it right here. Whoa. So, right, trinomial constant double the second equal to first. So we just have to ask, is it a trinomial? 1, 2, 3, check. Does it have a constant? Yep. Check. If I take that second exponent and I double it, do I get the first one? Excuse me. Yep. Check. So I'm going to rewrite this to be a quantity squared minus 13 times and then plus 36. And remember, we always take we're going to rewrite it in terms of the x squared, that middle term. So I'll write the x squared here in the parentheses and in the first one. And you have to ask, is that one equivalent to the first one? Sure looks like it, right? So I can do let a be equal to the x squared. And you get a squared minus 13a plus 36. Oh, it has a leading 1. So that's always nice. So we can write our two groups. I can write a and a. What are factors of 36 that add to be negative 13? Is it minus 9 minus 4? So then we can plug back in what a is, which is x squared. So you get x squared minus 9. And then here you get x squared minus 4. You do have to ask, can you factor again or factor more? Because we're in Algebra 2 now. Can you factor more? The answer is yes, you totally can factor more, can't you? So I notice in this first one, it's the difference of squares, x times x and 3 times 3. So I can make my two groups. One's plus, one's minus, and you get x in the front, 3's in the back. And here is x times x. This also factors, and 2 times 2. That's also going to be two groups. So x, 2, 2. I'll just write it one time here. So x plus 3. Can we factor this any further? Now they don't always both factor, right? I can make one of the terms factor further. Last one, uh-oh. So the one thing that we haven't been doing and we should be doing is we should always be asking, is there a GCF? This one has a GCF, doesn't it? Do you see 2 goes into all of them? And also x, and we have a leading negative. So I'm actually going to factor out the leading 2x. So this leaves me with negative 2x times, I'm going to divide all those by negative 2x. I get 4x to the fourth minus 3x to the second plus 1. Uh-oh. Okay, fine. Yeah, I forgot to change all the signs, didn't I? So let's go through and fix them. So it should be a plus 3x and then a minus 1, right? So let's fix that last one to be a minus 1. And all the signs now are changed correctly. Okay, we're to the 4th power. So I'm going to look and see if I have my check boxes here. I'll do right here. Okay, so do we have a trinomial? Like we're asking if we can factor again. So this middle in blue is a trinomial, isn't it? So I can check that. Do I have a constant? The answer is yes. Check that off. And if I double the second exponent, do I get the first one? I don't have room to write double there, so I'm just going to write yes. Okay. Actually, I should just bring it down a line, shouldn't I? I'll do that. Hang on, I'm just going to move this whole thing down. There we go. Now I can write double. So I'm going to rewrite that middle. So it's going to be the negative 2x times, and it's going to be 4 times something plus 3 times, 4 times something squared plus 3 times something minus 1. And remember, it's always the middle term, right? The variable that's in the middle. So in this case, it's the x squared here that I'm going to rewrite in the first and second parentheses. Okay, do you guys all agree that that line looks like the line above it? Okay, let's let a be equal to the x squared. So this becomes negative 2x, right, when we go to rewrite this line. And then it's going to be 4a squared plus 3a minus 1. Oh. Okay, now we have a leading number. So I am going to multiply that first and the last. So 4a squared times the negative 1 gives me negative 4a squared. That's going in the top of my x. In the bottom, I have 3a. Can you guys think of things that multiply to be negative 4a squared that adds to be 3a? How about minus 1a plus 4a? Does that work out? Yeah? Okay, so I'm going to use orange here, I think. So what I'm going to do is I'm going to replace the 3a with those two values, the minus 1a and the plus 4a. So I will rewrite this line down here. And so I have negative 2x times, and then I have, well, I'm going to use brackets. I'll switch those to brackets. 4a squared. And then instead of writing the plus 3a, I'm going to write minus 1a plus 4a, and then bring down the minus 1. You guys remember this factoring technique? You might do it off to the side and then just bring it back in. Now I can group the first two. So I can group here, there, and then start looking for a GCF. Is there a GCF in that first group? Yeah, I could take an a out, and I'm left with 4a minus 1 plus. Is there a GCF in the second group? No, I'm going to leave it alone, but I'll take out a 1, right, and then write 4a minus 1. Okay, so now looking at, let's see here. We have two terms. Do you guys see that? Right, we have this one here and this one here. Do you see that they both have the 4a minus 1 and the 4a minus 1? So, I'm going to skip a line here. Oops, that's not what I wanted. So I'm going to take the 4a minus 1 out. Let me write that in pink so that it... And then when you divide both those terms by 4a minus 1, notice that you're left with a plus 1. Okay, those don't factor further with what I have. So now I'm going to put back in what a is. Whoops. So 4, and then up above you can see a is the x squared minus 1, and then here the a is the x squared plus 1. We do have to ask, can we factor again or factor more? And one of them does factor, right? The x squared plus 1 does not factor, but that 4x squared minus 1, did you guys notice that they are, it's a perfect square here, right? 2x times 2x and 1 times 1. So I can rewrite this to be 2x times 2 groups, and then the x squared plus 1 there. And you can see it's going to be 1's plus, 1's minus, the 2x in the front, and the 1's in the back. That was a hard one, huh? It had the GCF at the beginning, it had the quadratic form, and then it factored again. So there's 3 different factoring within that problem, wasn't there? Okay, so with that, that will wrap up the lesson.